Section 7.6 Step response of an RL circuit. You can find a circuit on the slide as graph A. There is a voltage source. However, there is a switch inside, and the switch is turned on when t equals 0. However, the inductor could be charged before t equals 0. And we can rewrite this circuit as graph B and get rid of the switch by using the step function ut. According to the previous analysis, we should know the full response or the complete response. I has two parts. The first part is temporary part, and the second one is permanent part. So we can write I like this: I equals IT plus ISS, where IT equals A multiplied by e to the minus t over tau, where tau equals L over R, and A is a coefficient, and ISS equals Vs over R. So the solution of this circuit is I equals A multiplied by e to the minus t over tau plus Vs over R. According to the initial value, we can get the value of the constant I, because the current through an inductor cannot change abruptly. So I0 plus equals I0 minus equals I0. So the constant A equals I0 minus Vs divided by R. And we put the value of A inside, and we get the final solution. IT equals Vs over R plus I0 minus Vs over R multiplied by e to the minus t over tau power. So for the step response of an RL circuit, you should remember the solution is like this: IT equals I infinity plus I0 minus I infinity multiplied by e to the minus t over tau. And you can find the waveform of the current in the graph. However, if the switch is operated when t equals t0, the solution should be like this: IT equals I infinity plus I t0 minus I infinity multiplied by e to minus t0 over tau. So to find the step response of an RL circuit, you will require three things. The first one is the initial inductor current I0 at t equals 0. The second one is the final inductor current I infinity. The third one is the time constant tau. The time constant tau is just like the time constant tau for a source-free RL circuit, which means tau equals L over R. So you can find the current through an inductor, use this method. However, how to get the voltage across an inductor? You should get the current first, and then you can use the relationship between the current and the voltage to find the voltage. Vt equals L multiplied by di over dt equals Vs multiplied by L over tau r multiplied by e to the minus t over tau, where tau equals L over r, when t is greater than 0. This is the end of this section.